You breathed in just now. You did not decide to. You did not think about it, plan it, check whether the air was worth taking in. Your diaphragm contracted, your chest expanded, and roughly half a liter of atmosphere entered your lungs, the way it has approximately 20,000 times today and will approximately 20,000 times tomorrow, and has done without interruption since the first moments after you were born. You have never once had to worry about whether the air would be there. The atmosphere is the most reliable thing in your life, more reliable than any relationship, any institution, any technology. It has been there every second of your existence, precisely calibrated to sustain you, thick enough to protect you from radiation and meteorites, thin enough to be transparent, chemically balanced at a ratio of gases that your biology was built around so precisely it seems designed. And here is the question that planetary scientists and physicists face when they actually run the numbers on why the atmosphere exists at all. It should not be here. By every straightforward application of the physics governing planetary atmospheres, the temperature of the Earth, the mass of the planet, the escape velocity from the surface, the behavior of gas molecules at the temperatures involved, Earth should be a bare rock. The calculations come back wrong. The atmosphere that is sitting on your chest right now, that has kept every human being who ever lived alive, should have leaked away into space billions of years ago. It did not. And the reason it did not is one of the strangest, most contingent, most biology-dependent stories in the entire history of planetary science. And when you follow it all the way to its conclusion, you arrive at a place where physics and life become so entangled that separating them starts to feel like the wrong move. Do not take the next breath for granted. You are about to find out what it cost. Let me build the physics of the problem first, because the problem has to be felt before the solution can land with the weight it deserves. Every planet has a gravitational field. Gravity holds the atmosphere down. But atmosphere is not a solid, it is a gas, and gas molecules move. They bounce off each other, they absorb energy from sunlight, they heat up and accelerate, and some fraction of them at any given temperature are moving fast enough to reach escape velocity, the speed at which a molecule can climb away from the planet's gravitational pull indefinitely, bleeding off into space, gone forever. Whether a planet retains its atmosphere over billions of years depends on a precise contest between two things: the planet's gravity, which determines how fast molecules need to move to escape, and the temperature of the upper atmosphere, which determines how fast the lightest molecules are actually moving. Heavy molecules like carbon dioxide and nitrogen move slowly at a given temperature, slow enough that even over billions of years, relatively few escape. Light molecules like hydrogen and helium move much faster. For a planet Earth's size and temperature, hydrogen and helium leak away quickly. Other gases stay. This is why Earth has nitrogen and oxygen and not hydrogen and helium. Simple enough. The physics selects for the heavier gases, fine. But here is where the calculation becomes uncomfortable. Run the numbers forward from the early solar system. 4.5 billion years ago, the young sun was more active. It blasted the inner solar system with intense solar wind and radiation. The early Earth was warmer, its upper atmosphere was hotter, and atmospheric escape was far more rapid than it is today. Mars, which is smaller than Earth and has weaker gravity, lost most of its atmosphere this way. Venus retained a thick atmosphere, but it is a hellish one, mostly carbon dioxide, a runaway greenhouse catastrophe. The early Earth, by the same physics, should have followed a similar trajectory. It did not. And the reason it did not cannot be fully explained by physics alone. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. Let's find things out together. Let me tell you something about oxygen, because oxygen is the key to the paradox, and its story is the most important geological story ever told. The early Earth had no free oxygen in its atmosphere. Zero. Oxygen is a reactive gas. It combines readily with other elements, with iron, with sulfur, with organic compounds. Any free oxygen produced on the early Earth was immediately consumed by chemical reactions with surface rocks and dissolved minerals in the ocean. The early atmosphere was a reducing atmosphere. Nitrogen, carbon dioxide, methane, water vapor, various sulfur compounds. Breathable to nothing. Useful to nothing we would recognize as complex life. For roughly the first 2 billion years of Earth's history, this did not change. Life existed, microbial life, single-celled organisms running on chemistry we would find exotic. But the atmosphere remained stubbornly unbreathable, stubbornly different from what it is today. Then, approximately 2.4 billion years ago, something happened that geologists call the Great Oxidation Event. Oxygen began accumulating in the atmosphere, not quickly by human standards. The timescale was hundreds of millions of years, but inexorably, persistently, the proportion of atmospheric oxygen climbed from essentially zero to the 21% we breathe today. What happened? Photosynthesis happened. Specifically, a group of microorganisms called cyanobacteria developed the ability to split water molecules using sunlight, releasing oxygen as a byproduct. This was, from the perspective of the organisms then alive, a catastrophe. Oxygen was toxic to most early life, and the Great Oxidation Event triggered what is sometimes called the oxygen holocaust, the largest mass extinction in Earth's history, as anaerobic organisms were poisoned by the accumulating gas. But for the future of complex life, it was the pivotal event. Oxygen in the atmosphere made complex multicellular life energetically possible. The metabolic efficiency of oxygen-based respiration is roughly 18 times greater than anaerobic alternatives. Without oxygen, complex animals cannot exist. Without cyanobacteria, oxygen does not accumulate. Without the Great Oxidation Event, there is no you. Here is the analogy I want you to carry. Imagine a city that should be uninhabitable, too cold, wrong elevation, no natural water source. And then a small group of settlers arrives, and over centuries, they build infrastructure, reroute rivers, plant forests that change the local microclimate, engineer the environment so thoroughly that 1 million people can eventually live comfortably in a place that should support none. The city's habitability is not a property of the location. It is a product of the activity of the people who chose to live there. Remove the settlers and the infrastructure collapses and the city becomes uninhabitable again. That is the relationship between life and the Earth's atmosphere. The atmosphere is not a natural background feature that life happens to exist within. The atmosphere is, to a significant degree, a product of life. It was built by organisms over billions of years. It is maintained by organisms right now. And if the organisms were removed, it would not persist in its current form. Do you see what happens? The air you just breathed is not geological, it is biological. You are breathing the exhaust of billions of years of microbial metabolism, the accumulated byproduct of organisms that lived and died before complex animals existed, the managed output of an ongoing planetary biological system that has been maintaining the atmospheric composition with a stability that looks, from the outside, almost deliberate. This is the part that keeps me up at night. Let's be honest about what this means in terms of how we think about planets and habitability and the relationship between life and the environments it exists in. The Standard Model, in both popular culture and early planetary science, treats the atmosphere as a given. Planets have atmospheres determined by their mass and composition and distance from their star. Life, if it arises, adapts to the atmosphere it finds. The atmosphere shapes life. Simple directionality. Physics first, biology second. But the Earth's atmosphere violates this picture so thoroughly that it forced planetary scientists to develop a new framework. The Gaia hypothesis, proposed by James Lovelock and Lynn Margulis in the 1970s, suggested that the Earth's atmosphere, oceans, and surface are maintained in a state favorable to life by the activity of living organisms, that the biosphere and the physical environment form a single coupled system in which life does not merely adapt to conditions but actively participates in creating and maintaining them. The hypothesis is not mystical. It does not require that organisms consciously maintain the atmosphere. It requires only that the byproducts of biological metabolism happen to feed back into the physical environment in ways that stabilize conditions within a range compatible with life, and that this feedback has been operating long enough to shape the planetary environment substantially. The evidence for this, at this point, is not controversial. The oxygen is there because of biology. The nitrogen cycle is maintained by biology. The carbon cycle, which regulates the greenhouse effect and therefore global temperature, runs through biology at every critical juncture. The ocean's chemistry is shaped by marine biology. The soil's capacity to retain moisture and support further life is a product of biological activity. The Earth is not a planet that happens to have life on it. It is a planet that has been so thoroughly modified by life over 4 billion years that the physical environment and the biological system cannot be cleanly separated. You are not living on Earth. You are living inside a biological system that has made Earth into something livable and is maintaining it that way right now. Here is the disturbing implication, stated without softening. The stability of the atmosphere is contingent. It depends on the continued operation of the biological systems that maintain it. It is not guaranteed by physics. It is not guaranteed by geology. The 21% oxygen, the nitrogen balance, the carbon cycle regulation, the temperature stability that has kept liquid water on the surface for 4 billion years, despite a sun that has brightened by 30% over that period, none of this is automatic. All of it runs through biology. And biology is not indestructible. We know this is true because we have examples of what happens when the biological maintenance of a planetary atmosphere fails. Mars almost certainly had liquid water on its surface in its early history. Whether it had life is unknown, but it had the physical conditions for life. It lost its magnetic field early in its history. Without the magnetic field, the solar winds stripped the atmosphere away faster than geological outgassing could replace it. The water escaped into space as hydrogen. The surface dried. The temperature dropped. If Mars ever had a biosphere, it was not sufficient to maintain the atmosphere against the loss. The planet became what it is. The Earth's magnetic field is maintained by the churning of its liquid iron outer core, which is itself a consequence of the planet's internal heat. Partly primordial, partly the product of radioactive decay. This is not biological. But the other stabilizing feedbacks, the carbon cycle, the oxygen cycle, the albedo feedbacks running through vegetation and ocean biology, those are biological. The magnetic field is the physical infrastructure. The biology is the management system running on top of it. Both are necessary. Neither alone is sufficient. Here is the visceral consequence I want you to hold. Every breath you take is made possible by a chain of contingency so long and so improbable that following it back to its origins feels like trying to trace the ancestry of a single water molecule in the ocean. Cyanobacteria that lived 2 billion years ago and are now extinct produce the oxygen now in your lungs. Geological processes that have not been fully replicated elsewhere in the known universe maintained a liquid water ocean for long enough for those cyanobacteria to evolve. A planetary magnetic field maintained by radioactive decay in the core held off enough solar wind to preserve the atmosphere while biology was getting started. A moon large enough to stabilize the Earth's axial tilt prevented the kind of chaotic tumbling that might have made the climate too variable for complex life to persist. Every one of these factors had to be present. The absence of any one of them points toward a different outcome. And we know the different outcomes are possible because we can see them. Mars, Venus, every airless rock in the solar system, all around us in the same neighborhood, built from the same materials, subject to the same physics, sitting in the same sunlight and utterly barren. The Earth is the exception, not the rule, and the exception is maintained by the biology living on it. Now let me bring this somewhere it genuinely deserves to arrive, because the dark paradox is not just a reason for wonder. It is a reason for something rarer and more demanding than wonder. The atmosphere is a commons. It is maintained by the collective biological activity of every organism on this planet. Every tree, every ocean phytoplankton, every soil bacterium, every organism running photosynthesis or the nitrogen cycle or the carbon cycle right now, today, in this moment. You are a beneficiary of this commons. You breathe the output of 4 billion years of planetary biological maintenance without contributing to it in any way that the maintenance system recognizes or requires from you specifically. And we are right now intervening in the maintenance system in ways whose consequences we understand only partially. The carbon cycle, which has regulated global temperature for billions of years, is being perturbed by the release of carbon that was sequestered over hundreds of millions of years of biological activity. The rate of species extinction is altering the biological systems that run the maintenance. The chemistry of the ocean is changing. We are not threatening to destroy the atmosphere. We are not going to turn Earth into Mars in any human-relevant time frame. The biological maintenance systems are resilient, and they have survived perturbations far more violent than anything we are capable of. But resilient is not the same as unconditional, and the boundary conditions, the range within which the maintenance systems keep things stable, are not infinitely wide. And we are, for the first time in the history of life on Earth, a species with the capacity to push those systems hard enough to find out where the limits are. We are the first organism in 4 billion years to understand the system well enough to be aware of what we are doing to it. That awareness is not comfortable. Feynman would have said that discomfort is the correct response, that the discomfort means the understanding is real, that you have actually internalized what the numbers mean rather than noted them abstractly and moved on. You are breathing right now because 4 billion years of life built you a sky. That is not a metaphor. That is the physics. That is what the evidence actually shows when you follow it without flinching. The sky is not a backdrop. It is a product. It belongs, in a causal sense, to every organism that contributed to building it. And it is being maintained right now by the biological activity of every living thing on this planet, except the one species that understands well enough to feel the weight of that fact. We are the inheritors of 4 billion years of planetary biological labor. We are the first ones who knew it. We are so far the only ones who could choose what to do with that knowledge. The atmosphere held. For 4 billion years, through ice ages and mass extinctions and asteroid impacts and a brightening sun and every catastrophe the solar system could deliver, the atmosphere held. Life maintained it. Life rebuilt it when it was damaged. Life tuned it and adjusted it and kept it within the narrow range that complex organisms require. It held because everything alive was, without knowing it, working on the same problem. That is what you breathed in just now. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.